Welcome to Aeronautics Episode 2, Back to Basics. So, in this episode, I'm going to cover a wide variety of tutorial points. Um, some of this will be, very simple, basic things that I'm sure a lot of players know by now, and a lot of it's going to be material for those that have never really played Kerbal Space Program before. So, here's the situation, and here is how our tutorial is going to cover it. Off camera, I made a problem. Um, you see, I tried to launch a craft to the moon without any special navigation, uh, eyeballing it, and I did it. Um, I got within 14 kilometers of the moon, and then I shot past it, and it accelerated me so that my orbit is millions of miles away. But it comes back down. That's the good part. I'm not slung into the solar system away from my planet. I'm still in its sphere of influence for now, until the moon might interfere again and toss me even further and faster. So unless I hit it, of course, that would be another outcome. So this vessel is out of fuel, and it couldn't get home. It did get very close. It got to 460 kilometers. So this is our mission. Launch a vehicle that will intercept match velocities and orbit and perform rendezvous. So we're going to cover those mission points in the tutorials. The very first thing we're going to discuss today is rocket theory. My understanding of how it works. So here is the vehicle I had used to make the approach on the moon. We're going to need to modify this, but first let's talk about what rockets are and how they work. So before we discuss how staging works, which is next on the docket, we're going to discuss rocket theory, the basic principles, and the best way that I can convey them. For me, you start at the top because what we call the top, the end of the rocket, is called the payload, and its weight must be considered when designing everything beneath it. So I got this payload, and then it's got two big fuel tanks and a tiny little engine, a rocket motor. This one's a highly efficient one, so that should give me some more power. So the point is, put the lighter thing on the top. Give it a good little chunk of fuel. Not a whole lot is usually required, but in this case, I realized that this rocket was overpowered, so I had to add more weight. So I added more weight here, and I added more weight here in the form of fuel. So normally you might only want one of these. So, but anyways, put the smaller part on top. Put the bigger, more powerful stuff on the bottom with more fuel. Because this is going to be heavy and lifting a lot of weight above it. It needs a lot of power. So, use more engines. So this has these guys that are called solid rocket boosters. They're called that because they have no control over their throttle. They're like, you light them and they go, like fireworks. You don't have any control. They're at full throttle and they just go until they burn out. So then that's when we get involved in the staging. We'll talk about that in a moment. So as you can see, I have a lot of engines here. I've actually attached these four to the sides of the fuel tanks, and we'll discuss that more in depth a little bit later. So the point is, tons of thrust down here, tons of fuel to burn for a while. Then this stage breaks, and then it goes to the next one. So let's just dive right into staging and what that is. Rockets are basically vehicles that operate on timing. So certain events need to happen at a certain time or a certain criteria. And this is called staging. It happens in sequences. So the bottom stage, what you're seeing is highlighting as I'm hovering over it. That first thing to toggle or to trigger will be the big engines, the center engines, and the outer engines. That's going to be your first stage. The next thing that will stage when I press the staging button is these two decouplers. So obviously these burn all together, and then eventually this will be empty, so I'll stage the decoupler by hitting spacebar, which is the staging button while you're launching or flying a vehicle. So it'll stage, and then after a long time, this whole thing will run out of fuel. So I'll need to destage right here. So after this one that separates the solid rockets is this one. And then of course naturally is the next engine. And that's gonna burn until it's out of fuel and then destage. And then you've got parachutes. So it goes basically bottom up. So there you have it. Now that's kind of an explanation of staging in a very basic terms. So the next thing we have to prove is this vehicle on its own capable of matching the orbit of the craft that's up there. I'm going to change its name to Rescue. Alright. And then the next thing we're going to go ahead and talk about now is controls on the launch pad. We're going to discuss, a couple basic things that are often overlooked. So, first thing we're going to talk about is throttle. Your throttle indicator is right here on the left side of what's called the nav ball. Control goes throttle down, shift holding it is throttle up. X is cut throttle completely, Z is max throttle. Very simple, shift, control, Z and X. You got it, easy peasy. The staging button is spacebar, so if my engines are throttled up, the solid ones are already going to go when I press spacebar, so if I press spacebar now, it's going to take off. Let's rotate around the planet by speeding up time. And hope that the ship doesn't fall off the launch pad and explode into a quadrillion pieces. I wonder how long it's going to take for that ship to come back. Oof. It's going to be a while. Let's just wait. Oh shit, did it just leave? Yes, it's on an escape trajectory. And it's gone. Wonderful. Now, we have a problem. Houston, we have a problem. There was an event at some point during the time warp. And what happened was that this vessel got kicked out. Now, it's no longer under the sphere of influence of Kerbin, the home planet. As you can see, it's running parallel to it on its own course. It's outside the gravity and power of the planet, and a good distance away from it, and now it's on its own solar orbit. So let's return to that craft. I wonder if it's got any battery power. Hang on. I wonder if it does. I'm not sure. I'm gonna fly it anyways. So we're gonna talk about the nav ball here. This is another really important subject. So the thing in the center is the nav ball. In space, there really isn't any up or down. There really isn't any distinct way, but for the sake of mapping, they did describe conditions in 6 directions that were based on true north. And that's explained. Just read on it somewhere. There's a Google will help you. But I've read that. Jesus Christ, ship, would you stop spinning? Wow, it's spinning out of control. That's gotta suck. Anyways, so yeah, he can't. He's trying to slow it down as best he can. Yeah, I don't know if he's gonna be successful. I can't even slow it down. It's just going. But anyways, can I still move around enough to show you the other articles? No, I can't. So I'm going to go ahead and mock launch a vehicle into space and show you. I'm just gonna launch like just a little craft, just for demonstration purposes. There you go. I'm not even gonna. I'm gonna like revert it so it doesn't even technically happen. And this is gonna be tragic because it's probably gonna blow up. Okay, it's gonna go way too fast. Let's angle our. So let's talk about the nav ball while we're here. This triangular-ish symbol that's always centered in the nav ball is the direction your ship is pointed. You see this circle symbol that's kind of chasing it? That's the direction you're technically going in. You might be thrusting and aiming in one direction, but that doesn't mean that's the direction your velocity is taking you in. So it will chase what direction you're pointed in as long as you're thrusting in that direction. Oh, well. So we're going to skip ahead briefly and talk about re-entry. So, yeah, you're on a planet that's got an atmosphere. It's dense, just like Earth. You see, that's how fast my ship was going. That's meters per second. At that speed, and at this altitude, like where the atmosphere is still very thick, that atmosphere is hitting my craft at 1,200 meters per second. And when items collide at that speed, they create friction, which creates heat. Enough heat to cause my ship to explode. The same principle would be applied to a ship re-entering the atmosphere from space, because usually they're going faster than 1,200 meters per second. And to combat this, we use heat shields to protect the craft above the heat shield. So that craft did not have one because I wasn't thinking. But that's okay. We demonstrated a couple fine points about the nav ball, and we're going to get into those further in just a moment. For now, we need to discuss the obvious problem that we have a craft trapped in a solar orbit, and it has a lot of scientific data. Like, it's got stuff on the moon, not stuff from the moon, but science reports from near the moon on our first flyby up there. So, do I abandon him till I can recover him later, or do I pursue him now at risk of financially bankrupting myself? I think what I should do is refocus back on contracts. And I think that's a very important notion, is to keep yourself focused on the contracts if you're playing career mode, which is what I am playing currently. So we talked about the nav ball. I do want to talk briefly about a couple other subjects that I would have normally naturally gotten to had we been able to fulfill our mission, but we'll talk about them now really quick. First thing, let's talk about orbital mechanics. I'll try and keep it simple and brief. Things spin around things, okay? Big thing, small thing, right? And this is what you think is big, but actually the sun is big. So we're spinning around the sun. And so are a bunch of other planets. And more distant planets, right? So, and there's gravity, which keeps you planted here, right? So how do we combat gravity? We do so with speed. Speed will defeat gravity. Well, I wouldn't know if I would say defeat is the appropriate word. I'd say circumvent. It's not anti-gravity so much as it is just an opposing force. For example, falling at, skydiving, they reach a certain velocity and can't go faster. That's because their body is meeting wind resistance as they fall. So they are naturally unable to. There's a certain point where that wind resistance meets up with the speed, and it can no longer allow it to go faster, basically. So gravity is a force pulling objects down to larger bodies. So it's the same force enacted upon the moon. But you know what the moon's doing? The moon's moving. It's moving, around the Earth, and the Earth is pulling on it, keeping it. If it wasn't pulling, it would shoot off like my ship did. But it's being pulled in by Earth. It's still within Earth's sphere. And so is this other moon called Midness that's also orbiting Kerbin, if you will. So you defeat gravity to speed, but you can launch a craft, and what you have to do is, well, why not demonstrate this principle? I'm going to go back to the moon, ladies and gentlemen. I think that we need to go back there and correct our mistakes and learn from them. So let's do that. Let's shoot for the moon. Thinking I can't add any more parts because I have a part restraint. So because of my vehicle assembly building, I have a limit of 30 parts. So it's maxed out. So I could take something off and add something else, but yeah, we'll see. All right. Well, to the moon. So we're going to talk about the various science, if you will, behind what's happening. So this is a craft full of liquid fuel. It's got several engines at the bottom that consume liquid fuel and oxidizer, which combine to create an effect that creates thrust. Likewise with these two solid rocket engines. They're pushing up with enough force that is obviously going to be greater than the weight of the whole ship, and it's going to push them up and away. The force is going down, so the effect is to push them up, and they'll continue to go up and increase in speed at an accelerated rate until they have reached the outer edge of the atmosphere, and then can burn horizontally to extend, and you will see that very shortly. So let's begin by talking about some more launch controls. We got throttle down, so that's max throttle with the Z key. Now the T key activates SAS. What is my understanding of what that is? SAS is basically giving, in this case we got is that Valentina? Yeah, we got Valentina Kerman with us tonight. In this case, I'm giving her partial controls. She basically grabs a joystick, and if I'm pointing it this direction, she'll try and keep it on this direction. She'll resist the ship's natural will to, I guess, disobey in these early stages of space flight. So let us begin. We're going to press spacebar to ignite the first stage, and off we go. I'm going to press the D key to tilt right a little bit, just a little bit, because I don't want to, if it comes crashing down, I don't want it to land on anything that costs money. So she's wobbling quite a bit. I'm going to turn off SAS, because I think she's fighting with it way too much. She's fighting with it. Drop those 2 stages. So oh crap, we have a flip. This is bad. Knight, come on, catch it. Jesus Christ, we lost all velocity. This is a fail. Found the 90. Burning on the 90. Oh god. Stop bucking. Oh, she's shaking loose. I think I know why they're doing this. I'm going to revert this flight. I think I've solved the puzzle. The vessel has a lot of torque, so the reason why is I bet a lot of these engines have gimbal. Yep. So gimbaling is what allows an engine to move a little bit, to change the direction of the thrust, to turn and correct the ship's path. If you have enough engines with gimbal on them, they kind of fight with each other. So let's turn gimbal off by locking it. So it's locked for these 4. There's no gimbaling on that, and there is gimbaling on this, but we want at least one thing to have gimbal. that should prevent it from shaking around so much. Because it wasn't just the pilot fighting with controls, it was the 4 engines fighting with the center one. Alright, and engage. Yeah, much smoother. She's arced over just at the right angle here. Just hold her steady. So this craft, if it launches successfully, will reach a very high velocity and escape Earth's atmosphere. The question becomes, will it be able to, get to the moon? I really wish that it had enough delta V, which is the rate of change, if you will. This thing's going really fast. It's getting up there in altitude. It's getting up there in altitude. Yep, it's gonna get cooler and cooler in space. It's gonna stop burning my ship, which would be really nice. I think I'm overshooting it. Alright, disengage that engine. Let's check out our trajectory. Oh, not bad. Just 243. So, the brighter white is where I most recently was. The darker is where I'm going to be, or have been, but not recently. So I'm going to push my warp button, get up to the top of the orbit here. I'm going to burn. So as you can see, if I let it go, it's going to come crashing back down. I've got to burn and push this out until it goes in a circle around the planet. To do that, I got to burn completely horizontal, like this. And since it's going to take a while, I'm going to pause it until it's complete. I'll be right back. Alright, and we're back. So, I have made an orbit successfully here, which is good, but I'm not certain if I'm going to make it to the moon or not. My fuel is kind of looking scary low, so we're going to try for it. So you see the moon right there? It's actually heading that way, and I'm heading this way. So if I burn here, I'm increasing my speed, which makes this side go out that way. So if I burn here, it's going to push that out, and then by the time I rise up to that end of it, the moon will be here. So I'm going to space for a little bit, so I want my arc to go this way, so that when the moon gets here, my ship is there. And now I'm going to burn and hope for the best, because I might run out of fuel, which means this ship is doomed to be cast out into the solar system, just like the first one. Let's watch our fuel. You can zoom in and right-click on a fuel tank, and you'll see your fuel here. I'm going to have to stop it right here. Yep, it's definitely... Oof. Cutting it too close. I need to not... Nope, it's too close. I'm gonna mute, time warp up ahead till I'm at the height of my orbit. Attempt to do some manner of science. And recover the craft. Where we'll talk more in depth about re-entry. So, let's talk about science. In this mode of gameplay called career, there are 3 factors. You got funds, science points, and you have reputation to deal with. There's also contracts, which are a part of reputation. Science is in the form of points, which are achieved by using science experiments in various places called biomes. For example, an orbit around Kerbin is a biome. A certain spot on the map of Kerbin is a biome. A certain piece of the moon is a biome. Orbiting the moon is a biome. And orbiting low is a biome. So like there's various biomes where, each each science experiment yields different amounts and more for new things. So this, I'm gonna observe material space. I wager I probably won't get much from this because, oh, never mind. I misspoke. That looks like 37.5 science points, which I'm gonna keep on the ship. I'm gonna observe this one, mystery goo, 15 points. Go to the other side, right click on it, observe, and another 15 points. And then my vessel, the capsule where he is, or sorry, she is, I'll right click and crew report. Get some science there. Alright, so we are maxed out on science. We have plenty of fuel to return home. I think it's going to be a good idea to consider doing that now. So let's look at our orbit. Our goal is to bring this down so that we hit the atmosphere. Here's the catch. Too steep and you'll never slow down enough to actually be able to deploy your parachutes. Too shallow and you won't slow down enough to basically fall into the sky and continue coming down. You'll just bounce out of their atmosphere and then be back on space again. So gotta be careful. Now the atmosphere starts at 70,000. I usually shoot for about 30,000 because that's a shallow enough angle. Let's do that. Hope I have enough fuel left. And alright, so I killed the throttle with X, and then I just tap shift to bring it up. Oh, whoop, oh, too much, too much. Let's turn back and then throttle that way a little bit. There we go. Get that back up to 30,000. There you go, good enough. So now, we've expended all the fuel we need to. We don't need this stage anymore, so I'm going to, and this is something I do sometimes, not all the time, but just for fun, I'm going to spin the craft to hopefully add some centrifugal force to the decoupling. Just get it spinning, and then hit spacebar to decouple. That's cool. I love it. So now we can stop doing that. That'd be great. That will not stop doing that. That'll do that pretty much forever, until it collides with the atmosphere. So let's get ready for reentry. So during reentry, your heat shield, this device here, will protect anything above it. If you're sideways going in like this, and the atmosphere is hitting your craft like this, your heat shield can't save you. It's gonna burn this up, then burn this up, then just poof, you're done. You have to keep it pointed at, like, see, this is the direction you're technically going, right here, this yellow indicator. So if you point this way, you're gonna end up, it's gonna reverse in a second here, but you'll see. Being closer to the atmosphere. 300,000. Alright. So at this point, I'm getting close to entering the atmosphere, and I have my craft pointed in the opposite direction of the direction I'm going, but the nose, which is now the heat shield, is pointed toward where the heat's going to come from. As you can see, it's turning red. Speed up time a little bit. This is the atmospheric gauge. There we go. You can see it's dipping into the dark blue, and our craft is starting to heat up. As you can see, the parachutes are red. If I attempted to deploy them now, they'd be destroyed. So I'm going pretty fast, almost 3 kilometers per second. So that atmosphere is hitting me pretty hard. It's pretty hot. So let's speed up a little bit. And I'm still on the outskirts. Huh. Looks like I bounced out. Yep. I bounced out of the atmosphere. Damn. Alright, well, I guess we're gonna have to go around again. Fortunately, our orbit still is gonna push us back down into the atmosphere again, so we'll have a second try at this, but the only problem with that is that the heat shield does have like a limit on how many times you can do this. Like, it'll burn up eventually. It's called an ablator or ablator. It actually just disintegrates as it absorbs heat. Oh no, it's still good. Look at that. It could take a few more rounds. Come on. There we go. We're getting in there. Alright, so let's point the craft in the right direction. Have the pilot try and hold it there. Now you have really no control over the direction you're going. Your craft is not in a dense enough atmosphere to have any lifting bodies that could create lift for it. And even if it could, it wouldn't help. Oh boy. Oh boy. Get that craft turned in the right direction. There we go. There's a gauge on the screen briefly. That was the heat gauge. Something on the craft was heating up to the point where it might break, basically. So, we're still bouncing out of the atmosphere. Again, our periaps, our apoaps, this is still in the millions. It sucks. We're out of the atmosphere pretty much. So we're gonna have to go around and around a couple more times. I'm gonna pause until I get back. And we're back. Yep, I'm desperately trying to slow this craft down through any means necessary, including spinning, what we call tumbling. Hopefully nothing's going to blow up, because that would be really bad. Really bad, really bad. Let's reorient the craft if we can. I don't know if we can. We're in trouble. This is bad. This is really, really bad. Okay, start cooling down. There you go. Yeah, we're not slowing down enough to be saved by air resistance. It's not going to pull us in. And, well, we didn't lose a significant amount off our speed. So this craft is in trouble. There's nothing that really can be done about it except to kind of wait through it and grind out the speed. So I'm going to pause and do that until I'm in a capture. So I'll be back in a few. So it's come to this. We have an emergency. That craft that I was piloting before, this one, yeah, it ran out of battery power, which means that it could no longer rotate, no longer allowing itself to point its heat shield in the right direction. So it's going to get into the atmosphere and then blow up. So my mission is to intercept it, have its passenger take the science, leave the craft behind, and then bail. And then this craft will have enough energy to turn around and go. So I'm gonna get going. So I have to control this craft myself because it's got seating for two, but one of them has to be a scientist to extract the data from the other craft. So unfortunately, the scientist, this is piloting the craft, and a scientist, which is not a pilot, cannot be used for SAS, so I have to control everything, so gotta be careful. Do not flip on me, please. Hold her steady. Hold her steady. Unfortunately, I can't even set this guy as a target. Whoa, 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 whoa. Shit. Point this toward the ground. Shit. He's way out there. Shit. I can't catch up to him. Shit. The ship is so hard to control. Holy crap. So that's a no-go on this whole idea of sending a scientist. We're gonna have to do another way. We have to have a pilot on board. There's no way I can do this kind of a mission with a scientist. So I gotta get a third one. But I'm gonna kind of cheat a little bit. I'm gonna kind of force these two objects to share space. The guy in the center is not meant to leave his pod. He's going to be stuck in there. So I'm going to ditch the science because we don't need it. We do need the heat shield. There. And I would say strap on some more parachutes. Tuck them in here. Like so. There we go. And then attach this. Booyah. I'm going to separate these guys a bit. Here we go. So we have plenty of staged parachutes, and then this craft should be ready. I'm going to select the crew. It's going to have a scientist in the center. And there's no pilots. Crap. Go to astronaut complex. Hire pilot. Exit. Recruit pilot. Leave an open slot for the rescue of the person. And then over 30 parts. Really. Right, drop the parachute then. Unfortunately. Whoops. Nope. Okay. In the 30 count. Okay. Gonna have to catch up with it quickly. Get up there. I just realized one other thing. For this mission, we're gonna need to have the ability to target craft and know their different or relative velocity. It's gonna cost us dearly. Way too much money. Shoot. That's not good. Well, let's fly. Let's just go for it. Sorry to keep doing that to you folks. I just keep hitting ideas as I'm mid-flight. After all, that was just a simulation, right? Wink, wink. Let's go. Let's go. Hold her steady. Yeah, it's passing overhead soon. Oh, I don't know if I'm gonna make it. It's going really fast. Ooh. Ugh. Come on. Oh no, they're screwed. Totally screwed. Wait, did it just survive? It did. Oh, right. I have an idea. So, I'm wasting my time. If you warp through time and you're not playing as the object, it usually will skip through the atmosphere as though, you know, it were fine. So, if I warp through the atmosphere, it's still there. See? Whereas if I was playing as it, it would be curse bloated. So, looks like we covered a lot of the main points today. We got rocket theory to an extent. We learned a bit about staging, about controls on the launch pad, nav ball, a little bit about orbital mechanics, encounters in the rendezvous. We didn't get to really get to. EVA we didn't really get to touch on either. But science we talked about, and we of course discussed reentry. I look forward to talking about more of these points in the future. You guys have a great night. Thanks for tuning in.